-1 to +1.
Correct. So
So I
Guru,
was
if you,
giving the file names.
yeah, it requires numbers. Guru, can you print
Yeah.
train underscore data set there?
Train underscore
Data set.
dataset
That
or
is
data
what is,
labels features.
no, data set, because that is what you're feeding to that function. That is what the error he was getting. Krishna was getting. Train data set is being fed to that, right? So,
This
and
is
it
the
was not
dataset.
able to unpack it. So what's the format of the data? We'll just see here. Train underscore, not data set. Data set is an internal variable. It will have the value. You can print it out. It will have
One
the value.
minute.
It
One
will have the
minute.
value. So data set will have train data set. Whatever you last called it with, it will still have that value. So let's run it.
Now dataset is not
They're not
defined.
defined. It is an internal function of
Yeah.
this.
So this
Just
is
do train underscore data set. Yeah.
is again a
Yeah,
tensor.
okay, so it's a tensor. Okay. So we
Yeah.
can do a for each in train data set print each. Let's see if that prints out individual elements.
Or
Each. If you iterate through this guy, we just want to iterate and see how does it look like. Yeah. Colon at the top. Yeah, colon at the top.
what do you want to print, sir?
Each print each. Well, not sure what it prints. Maybe print each, whatever each is. Yeah. Let's see. Let's run.
His notebook will crash.
Oh.
Do you want to do that, or?
Okay, let's not do it. Let's park it for the end. But we'll just want to see. Okay, so train data set basically has both image in terms of NumPy
Okay.
array and label as this
Sir,
thing,
you
right?
can do
So,
one thing.
uh-huh.
Sir, for each of train data set in front of that in bracket, he can write 0 and then it should work.
Let's see if so let's do that. Let's do train data set 0 if it allows you to access it using the square bracket. You deleted that code? No worries then. Fine.
Yes, I
We can try it
deleted
later. No worries. So okay, this section 9 on the code, if everyone can see this, a code, this block 9 is taking each of the raw image data, and it is feeding it to the VGG16 model, and the output is in that shape of 5 into 5 into 512, right? Once that is done, let's see the next step. It is converting everything, train data set into that, validation data set into that, test data set into that. Now let's go down. So now it's a very simple model design. Yeah, if you can talk about the model design, can you just increase the font size again? Again, my window is smaller, so that's why. Yeah, maybe 125 is fine. That's it. Yeah. So yeah, Kera's input dot shape 5 into 5, 512. That is, we all know why that is, because that is the output last layer shape of VGG16. You just flatten this guy straight away. Don't do anything else. Just flatten this, whatever you have. And then you add a dense 256x in between, and then a dropout layer. That's it. So this dense and dropout is just, as you say, for some advantages, maybe avoid overfitting. And then you do a dense one, which is cat or dog, activation sigmoid. And then you have a binary cosentropy, RMS prop, accuracy, callbacks is okay, whatever the callback function, history model dot fit. Now, if you go down, what was the, but before we go down, what was the last accuracy you got? It's still running for you, right? But what was the first accuracy you got? First accuracy was around 69%. 81. Now see this last validation accuracy is how much? 97. So do you see the amazing lift? So that's the benefit of having a very powerful pre-trained model and fine tuning it, right? That's one way. There is another way of fine tuning it, running it. If you go to the GitHub code, it will allow you to run the same thing. I mean, not the same thing. Now you have feature extracted. Now you can do the fine tuning stuff with that convolutional base. And as you can see in this, okay, before we go there, yeah, good that you run this code. Can somebody tell me after how many epochs the model has started overfitting?
I think
from that chart?
This is already
from
the second epoch.
Yeah, second epoch onwards, it is hovering around 96, 97.
Yeah.
So that's why even 20 was not that required. Okay, so let's move to the third option here. Not third. This is the third option. Let's move to the fourth option. There are in fact 5 options. The fourth one is a slight variation where you use a pre-trained model and you augment your data as well. And the final one is where you fine tune the model by freezing some layers. Okay, so third option, are you copying from the ImageNet file? Sorry, GitHub file?
Yes, sir. Yeah.
Okay. So now, okay, just run it. Yeah. So you're now doing this. You're freezing the convolutional base. Okay, so you're not, as I said, you do not need to train the convolutional base, so you're freezing it. And now, see, this might take some time, so we'll be careful. If you're taking a lot of time, we'll just stop the code. But what you're doing is
Can I stop at only 5 epochs?
Yeah, let's do 5 epochs.
Okay.
One thing, what we'll just understand what that model is doing. See, we are freezing that convolutional base, saying we do not want to train it. We just want to keep it as it is. We will not update the weights while training. That is what that line 18 means. Convolutional base trainable false. Line 16, in fact, line 16 has that. Line 17 and 18, they are just showing you if you make it true or false, how many weights do you need to train, right? Now you are using the same data augmentation function, which is there in the top. Now let's look at the model. Hope everyone is following, right? Any issues? Okay. So Kera's input shape is 180, 183. Data augmentation inputs through the function. Now you are pre-processing the inputs through VGG16, and the convolutional base is anyway there, right? And now, okay, you might ask the question, what is it that you do by pre-process? So that's a function. So VGG16 expects your input to be in certain shape. Now you don't have to do it manually. Keras provides you a function VGG16.preprocess input that will take care of that. So no worries, no need to worry about that. That will VGG16 will do it for you. That function preprocess. Now you are passing it through the convolutional base, which you are not training. Please remember, you are not training convolutional base. It is trainable equal to false. Next layer onwards, you are training. Layers.flatten, you are flattening it. Then you are adding, just like last example, a dense 256 nodes layer, and then a dropout layer, and then a dropout of 0.5. And then in the last one option only, which is about cat and dog. That's it. Now, if you run it, rest all the things are same as code. Only additional thing you have done is you have taken, you are not passing, I mean, you are just running at the top, and you are running the top layer, and you are just augmenting the images. That's the only change compared to third option. This is the fourth option. Let's see how it looks. Yeah. So even 5 is looks like it'll take 45 minutes. No, it is decreasing now. Yeah.
Because the other code is also running. So
Okay. No worries. So Nidhi, your code is run for the second one.
Yeah, but the accuracy is lesser than the first one.
There must be something missing out there. Maybe.
Yeah, looks like.
Yeah, some either too little images. I mean, too low number. Yeah, so run it with the whole entire at least 2000.
Yeah.
Or even at least 1000. 1000 should be good as well.
Okay.
This is 58 is still running. 72% it has reached. Let's see. Okay, this will hopefully it will reach by the time we end the class. This will definitely reach by the time we end the class, so that's not a worry. The other one, what is your score? VG16. We can stop it actually, Guru, because it will definitely give you around that 97, 98. We'll just move to the last one. Yeah, this one you can kill it actually. I mean, just this particular, you can stop it. Do not restart the kernel. Just stop the kernel. It's already reached, but this is training accuracy actually. But yeah, 85. So yeah, let's let it stop. We'll do the, yeah, so that's fine. So that's fine. This will, please do this as well, and you will find that the only change was augmented data. Rest all is the same. Now we will do the last option, which is the fifth option here. We did first was simple convenant. Second was I'm writing it down actually just so that everyone is. Simple convnet, then simple convnet with augmentation. Third is pre-trained model feature extraction. Pre-trained model with augmentation. And last one is pre-trained model fine tuning. So I just sent this list of 5 ways you can improve image classification results. And as you can see, it is amazingly effective. And I'm saying, just saying, try it out based on your problem statement. If like in the first 2 methods only you have reached the desired accuracy, no need to go to the third one. You can try it out. But yeah, this one actually showed you 97% accuracy. Just now you saw in Guru's notebook, right? So now you are doing the fine tuning Keras thing. So what is he doing is he's saying everything above layer 4, everything below layer 4 will actually be non-trainable. We will not, because layer 4, the lower layers are actually generic, learning generic things. So anything above that will be trained, but only that section will be trained. Rest all will not be trained. Okay, that's what he's saying in the line 21. Top 4 layers are being trainable here, or top 4 things. Rest all is not trained. Oh, it is, even this one is taking 5 minutes for you.
Yes, sir. It is still, yeah, first epoch only.
No worries, but yes, accuracy is quite high. Let's see. So even here we can wait actually. Let's see, 63 epochs. Oh my God. No, 5 epochs, 5 epochs. Okay. Yeah. Okay, till this results are running, I would just try this out, the fifth one as well. I would like to discuss about maybe a project we can do, or an assignment. Maybe we can convert the machine vision assignment to a project. What do you think?
Sir, project is a good idea.
Project is a good idea, right? So let's. Yeah, go ahead.
Anyway, this will help us to have some real kind of experience. Second part is we anyway have to submit a capstone project.
Yeah, but this will, I think so. See, capstone project will not be done in groups, is what my understanding is, because I have mentored people in the past. But yeah, this one will be, as you said, right? I agree with you that having a practical project kind of experience will be helpful in the industry as well. So I typically give an assignment here. I typically take a Kaggle data set and give you a multi-class classification. Or last time I gave, I think, some other data set, right? But what can be an image classification problem? Can somebody give me a use case? We can convert it into a project and give it to all of you.
I know a very small one.
Ah,
Male versus female face extraction.
in what age?
I mean, if you have just any number of photos and you input the
Oh, okay, okay, okay,
images.
okay. Gender from the photo. You're saying.
Yes. But that's very common.
Acha, but yeah, that's common, but that's an interesting one. Maybe okay. Let's have some more ideas where we are solving some use case as well. I mean, this is also use case, but let's hear more ideas. And preferably multi-class, because this is again binary, which you just said. we did a binary in the class. Let's challenge the class to go ahead and do a multi-class classification.
Are you asking for a new idea, sir, or?
I'm asking for a use case, preferably from your industries, so that we can convert it into a project and do it as an assignment.
But we will need the data also, right? Image data also. So, for
Yeah,
example,
so we can find something similar on the web and share the data set.
and I was tempted to say differentiate between a desktop and a laptop. Okay, but nobody would have done it if I give this idea. But I have to get the data, I mean, enough data also, right? I can download few from Google Images, but we may not get in plenty.
See, now you know all these 5 techniques which I just noted down, right? So you are a master of classification in that way, in the sense, even if the data is less, you can augment it, generate more data out of it. Okay, that is one option. Yeah. And from Google, one thing we do is we take this. By the way, nowadays, in fact, let me. I was going to cover this in the last session, that is next Saturday. There are these new models called. So, for example, I think DALL-E is the model, DALLE. You might have heard of it. If not, it's a text to image model, right? You describe something in text and it will give you images. So DALL-E kind of model can be used to generate fake images for training your data, right? That is one thing. Apart from that, you can increase the size of the image set by using augmentation. There are other things. And in Google, you have this Chrome plugins, which you don't need to manually download image data. You can download at one go the whole 500, 600 images from Google search page, right? So those are some of the options to get some data freely from the web if you don't have maybe a Kaggle data set or something like that, right?
Can we do instead of male female the age classification kind of thing? So based on height.
Yeah, age will be good. Maybe you can. Yeah. So do you want to do maybe let's make it slightly complex. Maybe not just image features. See, age can also be because of some other feature like multimodal problem, right? So run a deep learning model, but apart from age, also, I mean, apart from the image, also take maybe some other numeric features or something else which is there.
Sir, one question for object detection. Is it the only Haar cascade is being used, or what industry uses now?
In object detection use case, you're saying?
For object detection from an image, I know about Haar cascade.
Yeah, Haar is, I was giving that example today in the morning about the face, nose and eyes, right? So Haar was very popular at that time, but Haar is no longer used in most of the industries, to the best of my knowledge, because deep learning has taken over. Yeah.
So now what we use in production?
We use what you just learned today in the class, the deep learning models.
Okay, so do we have any such thing as pre-trained?
Yeah, VGG16 is a pre-trained model which can be fine-tuned to your purpose.
So can we make a project like there are certain images and identify the person name using this model?
Okay, you're saying celebrity identification.
Yes, yes.
Yeah,
that's a
good project. In fact, there is a celebrity data set.
Yeah, we can
Guru,
find it.
Yeah, go ahead. Guru, you mind searching for celebrity data set in Kaggle? Yeah, go ahead, Nidhi.
I mean, I was referring once a Haar cascade was used to identify the celebrity names and everything. So the similar thing we can apply for this deep learning model.
Yeah, deep learning will do it really easily. Deep learning is good at identifying this thing. Not even Kaggle, it will be there on Guru. It will be there in celeb data set. I know 200,000 images. Now, what are the classes here? How many? 40 binary attribute. Let's see. Yeah, see the first one. That looks like an interesting problem. Small data set, it is training, it has a training directory containing 14 to 20 photos, each of the celebrities. No, this is a small data set actually. See, there is this, you remember the house price prediction we did in the first class. So there is this problem where apart from the numerical features, you can also upload the way the house looks and add it to the price prediction. Have you done that kind of problem?
No.
I was thinking maybe something like that would be interesting. What do you think?
When you want to add some qualitative feature.
Yes, along with the image.
So adding categories.
Category. So it will have unstructured data, as in the image itself is unstructured. If you assume that, if you take that as an unstructured, and the number of drawing rooms, whatever number of bedrooms and number of whatever the square feet area is like your numerical features. So let me.
Problem student not clear. Can you come again?
Yeah.
Hello?
Yeah, sure. I will come again. Can I share, Guru? Meanwhile, feel free to share your results, whatever you are getting with the full data set. Okay, let me open the.
In the first epoch itself, I got around validation accuracy of 97%.
Which one? Third one?
Last one, sir. Fifth one.
Last one. Awesome.
Yeah.
The year anyway will be doing better than that, right? So see, I will not pick this exact example. House price data set with images, Python. Yeah. So text features, I don't know. Maybe I was looking for. Okay, house price estimation by. So somebody, Ahmed and Mustafa, created this in their 2016 paper. House price estimation from visual and textile features, right? So you are taking this and predicting price. So this is what is happening. You are feeding it to a convolutional neural network. You are so let's just run through this. We will take this as a just a walk through the code, right? And let's feel free to ask any questions. Then we will come up with a project, something similar. First, publicly available data set includes both numerical, categorical attributes along with images. Okay, so I think this is the problem I was mentioning. Number of bedrooms, number of bathrooms, area, zip code, 4 images, bedroom, bathroom, kitchen, frontal view of the house. Okay. So let me share this as an example. You all can go through as well.
So there is something also related to the ECG classification in the Kaggle. So
yeah, let's just understand this one, what is happening. Okay, I just want to share this as an example because classification, hopefully all of us are clear. Now let's just see, maybe you add some, so typically in the industry, you might get a mixed set of problem where apart from classification, you have something else. And this is what that example is, right? This is your not this is your other numerical categorical features. Total of 535 houses in the data set. So 2100 images. We'll be pruning that number down to loading the house price image data set. We'll create or they are creating a corresponding tiled image. So they are reducing it to one image by making it tiled. The tiled image will then be passed through the CNN using the house price as the targeted predicted value. To learn how we can tile the images for each house, load house image function. That all you can go through, no worries. These are the columns: bedrooms, bathrooms, area, zip code, price. Load house at, so they have standardized the data set. You can go through it and then load the house images and then scale the pixel intensity. So they are doing what we have done in the morning. They have reduced it to 0 and 1. partition the training and testing data into splits of, till now everything is familiar. We want to see how the model has been designed. That's the key takeaway. Amarnath, but I answered your question, right? What are we trying to do here? This is not the problem statement for assignment. We are just going through an example. Okay. Split, they split it 75-25. Okay. Then max price is find and use it to scale our house price to the range 0 and 1. Okay, so they are scaling the output by dividing everything by max price. Okay, let's look at the most important section of the code. How are they designing the model? So this all is fine. Sequential to start with. Dense layer with 8 nodes, activation ReLU. Dense layer with 4 nodes. Regression check to see if the regression node should be used. If regress is not false, regress not equal to true, then model add or model regress equal to false, model dot add dense one activation linear. So if regression is required, then you add this, return the model. Otherwise, what are they predicting? Let's see. Create CNN. Height, width, depth, -1. Input shape. Enumerate filters. Conv 2D, 3-3 padding same. Activation ReLU. Batch normalization, axis stand dim, max pooling 2D. Flatten the volume. Flatten dense 16, activation ReLU, batch normalization, dropout 0.5. Number, okay. Multi-label this thing prediction, dense 4. Activation ReLU, regression node should be added. Dense equal to 1. Construct the CNN, model equal to model inputs X. Price predictions and the actual prices. Model create CNN. As you can see, the prediction is not so great. 58% off in house price predictions. That is really worrying. I would not trust this model, right? But you got the general idea on what kind of features, if you add, the model needs to be modified, right? So that's the whole idea. I'm just looking for maybe a multimodal data set. Okay, give me some time. I will share it offline. I'll pass it on to Pratik. He will share the project. But the idea will be I will give you something which involves classification, but also involves some other variables, right? That's the whole idea. So let me get some interesting data set. Hope that project is fine with you guys, right?
Sir, I had a suggestion if you.
Yeah, sure. Please go ahead, Pratik.
Sir, we can try something like number plate detection according to the color plate of number, like number plate color. Like see, like yellow color number plates need taxes, right? They need to be taxed regularly. So we can do like some ANPR detection, number plate detection, which classifies according to sRGB values.
That's a good one. So for that, I'm also covering the object detection. I will start today, but I will continue object detection and segmentation, semantic segmentation in the next class, right? So okay, we will think if if maybe we can give it in the next class, the project. That's fine. But let me think on that. But good suggestion. Thank you. Okay, any questions on this classification stuff? Before I move to, I will just introduce object detection. We will cover it in detail in the next class because I don't want to hurry through object detection. It's a very important topic. Any questions from whatever has been covered till now? I hope all of you are aware today, the most of the part of the day we spent in these 5 techniques. Please use them going forward in any classification problem you get, and you are bound to get high accuracy, right? Try these techniques from starting from number 1 till number 5 as and when needed.
What's if I have enough data,
and then one will be sufficient also. One will be sufficient also. But Krishna, I'll tell you, in real life industry, rarely you will get enough data. And some cases, so you will be the person who will be starting generating the image data set, right? So initially, this won't be this will be an issue. And also, there is one thing I have seen is in real life, there is sometimes, in fact, many a times bias in the data set. So you will have, for example, let me share an example with you. I was doing a project where I want to identify if a screen is cracked of a laptop or not, right? Now, what has happened? The bias, I'll give you an example of a bias. When a screen is cracked, they will switch it on, right? They normally switch it on, switch the laptop on before taking a photograph just to show the screen crack. And if it is not cracked, then they don't bother to switch on the laptop. Just assume the behavior of the technician in the repair center. Now, because of that, what model has learned is if the machine is on, then the machine is cracked, right? So that's something which, and if the machine is off, then the machine is not cracked. Now, see, that is a dangerous thing to learn because maybe the model's power is also gone, right? It is nowhere you can switch it on. Then it is off only, you took a picture, and then my model will think, no, this is high probability that will be switched off. So in this cases, we need to augment the training data set with images artificially where it is cracked and off. Okay, and that will give you a higher probability of getting a correct prediction. You got my problem, right? So these techniques will also help you in special cases where your data set is imbalanced and is biased.
Good use case.
Yes, they're coming from real life. It has to be good use case.
Yes.
Okay, so since next week we'll be rushing through completing the module.
I will not rush to. I will ensure that everyone is, because see, these three things are very important. Yeah.
I didn't mean that way. Meaning to say, like for us to grasp the concepts.
Yeah.
So can you talk a little bit about how the exam will be? Because until the previous one, we wrote the test on the same exam day, live.
Yes. So typically, so I'll tell you my experience. So if next Saturday is the last class, then the Saturday after that is the exam. That's how it has happened with me, right? So I hope you guys are also expecting the same thing, correct?
Yeah. So what happened with the previous NLP class was the question was given 1 week before, and we were given the whole week for us to prepare for it. Prepare as in to write the code, and on or before the exam date, we had submitted. This is the first time for any module it was done like that. Given that the time it takes for execution, availability of the resources, etc. So unlike the past one where the machine learning execution is quick, faster, the last one needed more time to code and execution. So will we be having a similar pattern or?
I usually believe in traditional exams where you are given 2 or 3 hours, whatever, and then you solve it by sitting at your home and solving it on your system. It has worked for us in the past. I mean, what you are saying is also looking like an open book problem where I give you maybe a research problem where you take the whole time and run it, right? I would prefer a traditional exam, right, where you are time bound and you are given whatever 3 to 5 questions to solve.
Will you mind talking about the pattern, sir? I'm fine, sir. Will you mind talking about the pattern?
Yeah, pattern of the questions. Yeah, so definitely. So questions will be multiple choice quiz. I already have taken today, so there will be no MCQ in those. I usually prefer giving people very short theory questions, very minimal, maybe 5 to 10 marks, where the theory questions will just check your knowledge, and not memory. I mean, again, it's a it's a difficult thing to say. Maybe some amount of memory, but again, it will be something which it will be like the MCQ thing. What I just covered today, it will be from the class, and then I provide data set to you, and I give you questions. I mean, problems to solve using deep learning, and there might be Kaggle data sets. There might be some other data sets. So it will be some amount of theory questions in the beginning, and then maybe 3 to 5 coding questions. That's how I give actually.
Okay, got it.
But you asked like 2 weeks before the exam, so that sounds good. You are actually preparing from now itself. That's good. And I will say if you have paid attention in the class, your preparation is already done. And not just you, everyone I'm saying, not just you. Yeah. But and the idea here is, apart from that, I want you, once the course is complete, I want all of you to be like really comfortable in doing deep learning in NLP, whatever we have covered. And of course, machine vision, object detection, semantic segmentation, and some other state of the art models which have come in over the last 6 months, which I'll be covering next week, including some of them. Of course, even I don't have access to the code base, but I still would want you to like you to be aware of those, including vision transformers. Vision transformers, have you heard? Where just like NLP has transformers, the transformers are now also used for machine vision. And their OCR output is amazing. They are able to identify handwritten notes very accurately. Have you heard of them before this? Okay, so we'll cover them next week. Any other questions before I quickly introduce you to object detection and then do the rest in the next class? I'll start it now.
Do we have any assignment for today?
I will share it with Pratik. It will be a project kind of assignment. Okay.
Okay.
Give me some time. I'll work on it and I'll share with Pratik by tomorrow. If it's a project kind of thing, Pratik, I think we can give 2 weeks to people, right? That should be okay.
Yeah, sir. I'm not sure about the deadlines, but like, yeah, 2 weeks.
Yeah,
But
because it's a project kind of
exam
thing. So sorry.
Sir,
Yeah,
exam.
so 2 weeks if we give, we will not have the assignment submission date on the exam date itself, but maybe a few days after that, so that
Okay.
people can focus on exam on that date, and meanwhile keep doing the assignment and then finish it off and submit it. How does that sound to the class? That's okay, right?
Yes, sir.
Okay. Yeah.
Okay, so let me share my screen. I will start with something very basic in object detection. Oh no, this is semantic. What does YOLO stand for? Anybody knows? I'm sure some of you know, right? If not, no worries. I will just learn. You only look once. Okay. So YOLO is you only look once, and one of the very popular object detection models right now, I think YOLO V5 was there. I think they have come up with YOLO V6. I'll show you YOLO V5. YOLO V6 can be similarly done. No worries. Can be used. So object detection is a computer vision technique for locating instances of objects in images or videos, right? So this is an example of object detection. It is identifying car, it is identifying person, it is identifying a handbag, it is identifying whatever. YOLO object detector is doing that, right? Now, what are these boxes? These are the bounding boxes. It's called BB, bounding boxes, okay? So why do we, okay, here's a question for the class, thinking, food for thought. Why did I cover object detection after classification? Is there a connection? What is the connection? Can somebody think and tell me? Intuitively, logically, what is the connection between object image classification, which we just covered, and object detection? And why am I covering object detection after that? Even though here we are not saying that this image is a cat or a dog, but we are saying, okay, this portion of the image is a car. So how do you move from image classification to object detection? Let's just think and discuss.
No, then if in one image we have a cat and dog, then we can label it.
That's a good answer actually. What anybody else who wants to take an attempt at the same answer? I mean, or state your views on that. How do we move from? How do we use our learning of image classification and move to object detection? Very fundamental, very fundamental. I no right or wrong answer. Just think about it. How do you, if you know only image classification and you don't know anything like a YOLO, how do you make your object detection model?
So on the road, we can first identify how many objects are there, and then we can classify it's a two-wheeler, it's a four-wheeler, it's a truck, mini truck, and these kind of things. And human.
That's a good point. But first point, I don't agree, right? There is a issue, slight issue. See, when you detect the objects, for that you need some model. You cannot detect like that, right? So your second question was, your second point was correct. You need to then classify them. So what we do is very basic thing is, let me use a highlighter or a pen rather. Okay. So if you take this image, for example, maybe we divide it into these sections, maybe 15 to 50 pixels or whatever, right? We do this, okay? And then each of these section, we run a image classification model, and that tells us when we do, okay, here, till here, nothing is coming, okay? No, nothing in our classification system is coming. Now here, suddenly we came here in this section, it said car, okay? Suddenly we come here, it said car. Suddenly we come here, it said person, okay? And here also person. Now, you understand what I'm saying, right? So now you said, okay, I divided this image into sections. I ran classification models separately, and looks like in this section there is a car, in this section there is a car, in this section there is a person in this section, but it's like a very small percentage, and here it's also a big percentage, right? So I will do some calculations. I will check nearby what is the box is saying, and then I will draw this box saying, okay, looks like this. I will further reduce this maybe sizes somehow, and I will zero in on the exact location of the person, right? So do you agree that is maybe a logical extension of image classification to do object detection, right? Multiple sections, keep on doing image classification and then learn, okay, what is it that is, what's the image in this section? And if it is that image, then okay, let's draw a bounding box on it. Okay. Does that make sense?
Looks very complicated to me.
Yeah. See, again, that's like, see, typically these ideas when they start, that's how you do it. But then again, deep learning takes over, and deep learning. So there was something called as RCNN, which has become outdated now slightly. I would not be covering it. I will share a link with you because it doesn't even work with TensorFlow 2.0, right? So in one of my first classes, I used to cover it, but then sadly in the like last 2 years RCNN has become obsolete, but it is a very good example. It was doing exactly same thing what I just told you. It was doing CNN, applying CNN in sections of the image and then coming up with it again, predicting which section has what is also an additional model. But again, it's like the concept at a high level is the same what I just told you. And yes, it is complex, but the deep learning makes it easy, right? That's the thing. But let's now look at various types of object detection models. And by the way, what I explained is a simplified explanation of what happens, not necessarily the exact way YOLO V5, which is maybe state of the art, does. We can check it out. How does it do? We will cover it, right? But just this was just to give you an intuition of how you move from object detection, image classification to object detection. So, yeah.
Sir, is it just a simple uh, segmentation of a huge image and then adding it up, or just starting from a one corner with a pixel and integrating over whole of the area of image?
I like the way you first described it. Segmentation of the image is fine. Variable length segmentation is what I can call it, right? Variable length segmentation, do it. Then compare your results at the end. Okay, with this kind of segmentation, this is what I got. This kind of segmentation, this is what I got. So to do all this also, you need a deep learning model on top of whatever you are doing for after segmentation, right? So variable length segmentations, and then come up with the final output, which explains your segmentation outputs. Sorry, which explains the classifications which you got in each segment, right? The best way.
So for one image, I can break down into multiple segments in multiple ways of multiple shapes and sizes.
Yeah, but again, it is not infinitely variable. Otherwise, you will never end the process, right? It will be like in a series of, again, we are going into gory details of how internally they are created, but maybe it will be you take a 5 into 5 pixel, then maybe you take 20 into 20 pixel, then maybe a 50 into 50 pixel, and then keep doing that. That's maybe a set of images. Honestly, I'll have to read up on what are the steps, sizes of these boxes which they take, right? But that is how it works at a high level.
Sir.
Yeah.
Can we say that we are creating multiple bounding boxes and we are optimizing it based on the pixel densities? And say, for example, there is a cat and a dog in a picture, like the bounding box will be still optimized to just segregate the cat and the dog separately.
See, you brought an important concept here, right? This bounding box says there is something called as IOU. Have you heard of that term before? Intersection over union. We will cover that. I plan to cover that in detail in the next class. So please bear with me.
Okay.
The boxes which you draw, those bounding boxes, you will have multiple candidate bounding boxes. A deep learning model will decide which bounding box is the best for you. Okay, that's what is happening. And that is a metric, and IOU is related to that, intersection over union. Give me some time, I'll cover it in detail. Any other questions? As I said, this is just an introduction. We will deep dive into this. But I still want to show you one tool, slightly outdated, but still I like this actually. Can everybody try this? By the way, this is, have you heard of a data set called COCO data set? It's an image data set. It is a pre-trained model, and COCO dataset is having so many classes. So all YOLO models of object detection can by default predict this. So if your business problem is about detecting, not predict, sorry, detecting. Detection is also a prediction. It is predicting bounding box, right? As I told you. So if you want to detect these things in your business problem, you don't have to code anything. I mean, you have to code a few lines of code, of course. You can call YOLO V5 and it will, or YOLO, and you can use it. And I will show you how to use it. But it will just predict all these. So hot dog, pizza, donut. So for example, I have used YOLO V5 for computer parts, remote, keyboard. Then even TV is there, I think. Where is TV? Can you see TV here? Cell phone is there. Refrigerator is there. So these are already in a COCO dataset. These images are there, and YOLO has been trained on COCO dataset. Okay, so Image AI provides very convenient. So let me just try this one out, and that's. I mean, I will, and then after that, I think, yeah, I will then do YOLO and other things in the next class in semantic segmentation. I'm pasting this. I would request somebody to just try this Image AI. I am stopping the share. One of you can pick it up and just show it on the screen to everybody. I think there'll be some amount of code, very minimal. We can run it. Did I pick? Amarnath, you want to do that?
Yes, sir. Yes, sir. Once again.
Oh, sure, go ahead.
Please let me know if you can see my screen.
Okay, sure. It's still coming up. I think for me, it has not come up. Anybody whose second model has run or third model, please feel free to share your accuracy meanwhile. We ran 5 models today, by the way, or 5 versions of this exercise. So it'll be good if you can share your accuracies.
It is showing shared.
It is now coming up. I can see your screen now.
Okay.
Okay, so it is, I think, yeah. So Image AI can detect okay, it is using YOLO v3. That's why it is outdated now that we are using YOLO v5, but still it's a good example. Image AI provides very convenient and powerful methods to perform object detection and extract. It extracts images from the object. So if you have a cycle in an image or a car or whatever, it will extract the cycle and show it separately as well. The object detection class supports RetinaNet, YOLO v3 and Tiny YOLO v3. Object detection, okay, that is fine. Once you download the object detection model, you should copy the model file to your project folder where your .py files will be. And first, and then the write. So basically how it works is go down, scroll down, please. So you download one of those pre-trained models. They're not huge. They're 30, 40 MB, some of them. Then you import this from Image AI detection, import object detection. You detect object detection, detector set model as type YOLO v3. Okay, actually, in fact, I can give you a Google Colab for Image AI so that you can run it there directly. It will be faster. Amarnath, can you try this link? I found this collab link.
Yeah.
Just a minute. Everyone can use the collab link also. Yeah. No, not that one. I have still, yeah, this one.
Okay.
Yeah. Yeah, I think you can. I mean, you can mount your Google Drive. I think because it is looking for images. You want to do that first?
Yeah, yeah.
I would request everyone to do this. Run the code. This one which I've shared.
So just a second. I'll share in a moment.
Yeah. No worries.
System is actually quite done with rolling sound.
Sorry. Issues.
No issues. I'm just closing.
Okay. Yeah. You can mount it and then share again.
Yep.
We'll also, I think one thing we'll do in the next class is apart from these machine vision examples, we'll also fine tune some NLP models, BERT models. That's also part of the agenda. Still working on some other things which have come up in the last few months. I'll choose one of them. Few of them, not one of them. whichever I think are really important for the industry. Is it done, Amarnath? Oh yeah, yes, you're sharing again. Okay, that's fine. Now you can just do the other steps here. I hope you are running GPU, right? Yeah. And install all dependencies. That is fine.
Below also, I think we'll on below.
I think they will install it in the next section.
Okay.
Yeah.
Okay. So one thing, sir, so what the problem you discussed early in the morning? No, I lost a lot of time in fixing something. So I think either we should follow the database that you shared, that ImageNet or that image database that is you are using in your GitHub link, or we should use if we are using Kaggle, then we should use that.
See, Kaggle, the reason we use Kaggle is because it had already uploaded the images. It was Kaggle image. What we can do is in advance. So normally, if we have the quiz in the morning, then I tell people to download it also. Like what we'll do is we'll inform in advance so that you can download the data and upload it to Kaggle, so it will be faster. Sorry, upload it to Collab. Upload it to Collab.
Yes, sir. What I'm saying, trying to say that because the data it is already, I think, in the NumPy array format it is there, but so it is otherwise no, it is doing a lot of processing with right this. So those stuff I quite messed up actually here.
Yeah.
In
So
the
I would say refer. I'm following Francois Chole's book, right? So whatever is given there, we can follow that. Is what I would say.
Okay, so let's go
Yeah,
there.
that's the final. Yeah. So any confusion, just reproduce that code here in Google Colab, and that should be fine. That would run for sure, because that has been running for a long time now. Yeah, and it's updated. It's for now TensorFlow 2.6, so it's latest. I think it requires some image to be there. What's the error you got? Sorry, can you go down? Batch normalization. Anybody who's faced this issue and solved it, let us know, please. It also might be because of maybe compatibility issues, because your TensorFlow, this requires an older one. No worries, if you can't run it, let's not worry about it. If it is due to compatibility issues, but if somebody is able to run this, can anybody confirm if you're able to run this code, ImageAI? Guru, can you share the code with Pratik? Because I think you have followed the Kera's thing, right? The Francois Chole's Python books code, GitHub code. So Pratik, if you can take the code from Guru and upload it on this thing as day 3 code for classification, all the codes, that will be good.
Sure, sir. Sure, sir.
Yeah, and Amarnath, you can refer that as well. That's the code which would work. Okay.
Yeah. Cannot import name batch normalization from Keras normalization.
Anybody who solved this issue in the past or just now you have solved it?
What is image AI here?
That's a module.
Amarnath, try pip install image AI.
Sorry?
He's asking keep install image AI.
Okay. Have we done that already?
Oh,
no worries. Let's do that.
It is not here at least.
Yeah, but it is doing that, no? Last line?
This last line? Image AI. Collecting image AI, downloading, installing collected image AI, successfully installed image AI version. Yes. So what's the problem? Okay, let me try.
No, I mean,
I got your point.
yeah, let's see. It's already satisfied. No, again, my suspicion is this is because this is like YOLO v3, right? So it probably is looking for a TensorFlow version which is lower than this, and it is not finding that batch normalization function or module within that. That's what the issue is causing it. Okay, let's park it for now. I mean, this is just an example. You can look at that other link I sent, the GitHub link, right? Maybe that should help you as well. If not, let me know. We can take this up in the next class. Anyway, this is like just a useful GitHub link, but the main thing, YOLO and other things, I'll cover next week in the next class, right? Just FYI. So we can park this for now. Anyone who has run it or anyone whose accuracy numbers are there for maybe the other models classification, can you please share?
So for the fifth model, it is coming around 97.
Yeah, and your first model was how much?
81.
81. So it's a huge jump.
Yeah.
16, absolute 16% accuracy is like crazy. You'll probably get a award from the CEO. So that's amazing. But again, as I said, this was a simple data set. But in industry also, it has worked where I mean, especially in cases where there is less data, the pre-trained model approach always helps you a lot. So I've known that for sure. So whenever you hit less data problems, try pre-trained model approach. But one challenge is the data set which you have, the classes should be type of the labels which that model has been trained on. So you can find VGG16 predicts like 100 categories. Now, if you are trying to predict the motherboard of a laptops, the components on that, then it will be an issue because none of those classes are similar to this. Cat and dog is similar to any other animal, so it can be used there. But you got my point, right? So you can use pre-trained model only when your classes are similar to what a pre-trained model has been trained on. Not exactly same, but similar. Okay. Okay, so that case, let's end this today. Any no other questions? Sorry, you're saying something? Okay, we'll end the class. We'll meet next time. We'll